Thanks for coming. I wanted to give you a chance to introduce yourselves, and I know you came out with a book not too long ago, and it'd be great to learn about the book that you wrote. John?
Recently, Nina Zumel and myself wrote a book called Practical Data Science with R, and the emphasis of the book is the actual practice of data science. That there's a lot of books out that do wonderful jobs on the math, and this is sort of the more of a holistic, how do you do every step it's a very important topic because we think this drives most of the success and failure of data science projects.
Yeah, that's really interesting. Can you tell us a little bit about the projects that you've done and what you've seen as the best practices? In particular, you talk about the critical success factors for success and failure. Can you guys talk a little bit more about sort of the overall approach? You talk about practical data science.
Right.
What do you think makes it practical, and what have you seen with the customers that you work with?
We've worked with a lot of customers of a lot of different sizes. We've worked with some really large customers like EMC. We've worked with some very small customers like FlipTop, which is a company that John is currently working with. And what we've actually found is that the really successful projects have hopefully both, but either one of two things. One is really well curated and organized data. That is, they know what the data is and they know how it's organized. And the other thing that they hopefully have are people on their team who are really invested in the data science process along with us. So they're not just handing us everything and going, okay, just build us what we want and call us when you're done. They're actually willing to sit down with us in the problem-solving process, helping us work through the data. Since we're coming in as outsiders, we're not as familiar with their data as they are. Those are the two big, in my opinion, really successful things that make for a really successful data science project.
So you talked about two aspects. The first one had to do with curation of the data, organization of the data. Can you guys talk a little bit more about what you've seen with the customers that you've worked with in terms of the challenges? When we talk to data scientists, we hear that some of the challenges entail going back and forth with the data engineering team. It's a little bit challenging to get to the right data, so to speak.
Right.
It'd be great to hear your experiences, and in particular, if you guys have had experiences, with Hadoop and big data in general.
Right. Well, some of the issues that we've seen are in larger organizations. Often the data that you're working with doesn't directly belong to the person who's running the data science project, the group that we're actually working for. So we have to reach out to other groups to find that data, to get permission to use that data, to understand what that data is. When there are PII, personally identifiable information issues, there's a lot of back and forth about what we're actually allowed to see, which there's conflict often with what we need to do and what we're, in theory, allowed to see. So that's one issue.
So you talked about how hard it is to go back and forth with the different business units to find the right data. What would be interesting to talk about is how ready do you find the different business units to be able to provide you with the data that you need? Is it a very manual process? So if somebody has sort of a big data environment, if they really know what's there, how easy is it to work with the data and find what you need?
Often not, because often they're collecting that data for an intention that is not what we're there to help solve. So they're collecting the data for one purpose and deciding they want to use it for something else. So often they've not really looked at those aspects of the data that we're going to be working with, so they don't have a good idea of its cleanliness or its usefulness or its validity. We've had issues like that. We've had issues with schemas being reused. So originally the schema was used to support this task, and then they had another task they wanted to do. And they've just sort of, rather than completely coming up with a new schema, sort of recycled the schema they've got, which means that the names of data fields are not always what they really mean, and they can be outmoded or deprecated or no longer used for what the name actually says.
Yes. Yes, that makes sense.
Yeah, and just to emphasize, with some of the larger clients like a regional bank, we've used data from their compliance department, which is incredibly clean, but was not designed to support revenue or profitable analytics. So it contains a lot of very sensitive information you have to be respectful for. And then we've seen other clients, some in the Salesforce advisory environment, where the data was designed to drive the business, but it's a very cowboy schema, as Nina said.
Yeah.
Like you have columns named float 1, float 2,
Yeah.
float 3, instead of revenue, profit, and so that's a challenge.
That makes sense.
And I think also we've been most comfortable with the so-called SQL-sized clients, that they've gotten a large Oracle installation, something that handles actually quite a lot of data, but supports a very nice query interface. And as we've moved to more Hadoop clients, it's kind of a step backwards. You have a lot more capability in Hadoop, but you lose very simple concepts like schema and key constraints. It's not even documented. You have rows, you don't even know which columns are keys, even if they have that concept. And that actually drives a lot of difficulty. As you move to Hadoop, you're moving to a larger data scale, but you don't always realize how much you're giving up during that move from a traditional database.
Yeah, that's very interesting. We've definitely heard that from the various data scientists we've talked to. The fact that Hadoop is a file system, there's no data dictionary,
Right.
and you really don't know what's there until you go and actually look at it, which is of course difficult in Hadoop because there's so much data. And if you're trying to do a data science project, what we're hearing is it takes a lot of time to really go and find what you need, and it takes a lot of back and forth.
Right, definitely.
Yeah, I mean, in case in point, not at the Hadoop scale, because we're not here to make fun of Hadoop, but for a recent client, I was given their data to look for something, which I can't really discuss what it was, but so I loaded their data and started documenting the steps, and only after step 5 did I realize the column that they claimed had the important data was all zeros. Not mostly zeros, it was entirely zeros. And so you just always stuck between this cowboy, should I go look at the data first, or should I successfully document the tree